So, sampling distribution models, okay. For a proportion, provided the sampled values are independent and the sample size is large enough, sampling distribution of, again, this is supposed to be this little hat over top of the P, just for some reason, likes to put them beside. Don't really know why. But anyways, it's modeled by a normal model with mu sub P hat is equal to P, and the standard deviation of P hat is equal to the square root of PQ over N. Okay, just so it's rewritten so that it makes sense. So, in a really large bag of M&Ms containing 500 candies, we found that about 12% of them were green. If the company claims that 10% of the M&Ms produced are green, is this an unusually large proportion of green M&Ms? So, this would tell me that my mean is, 10% or 0.10. Okay, so then standard deviation would be the square root of PQ over N. So P is success, which is 0.1. Failure would be 0.9 over the amount N, which is 500 for this one. And then go to 3 decimal places. Point 013. So now we have our mean and standard deviation. We can draw a model.
Whoa, that's large.
I don't know why it did that. That was weird. Our mean value is 0.10. 1 standard deviation, 2 standard deviation, 3 standard deviation. Oh my goodness, what is happening? So 1 standard deviation away would be 0.113. 2 away would be 0.127. 3 away is 0.140.
Blessings.
The other direction would have 0.087. 0.074. And 0.061.
How did you fit all
Oh, I am so dumb.
that? Me too.
Goodness gracious. What was I thinking?
Is it? Oh, 074?
Yeah.
I didn't even get a day off. But now I have Mondays and Fridays. So that's exciting.
All right, so what do we consider to be like unusual?
2. More than
Anything beyond
More than
point 0.87 and point 113.
Okay, so as long as it's in this range, yeah, well, right, you answered what I asked. So as long as we're in that range of 2 standard deviations away in either direction, it's not unusual.
I thought it was 1.
It's 2. But you said the right numbers. Pretty
Did I?
sure. Pretty sure you said the right numbers.
Okay.
Subconsciously, you knew it.
Subconsciously, you're right.
All right, so we found 12% of them to be green. So,
That would
is
not
in
be
between it.
unusual.
No, it's not unusual.
okay, it's not unusual because it's in between. So, no, it's not unusually large. %12 is less than 2 standard deviations from the company's mean. So it's not unusual.
Sometimes, I mean, I understand that this is a stat class, so obviously we're doing stat stuff, but I wonder who actually sits there and looks at their M&Ms and goes,
Well,
I think this is unusually
obviously
high.
the company has to. Somebody gets paid to do that.
but like, why does that matter? Like, genuinely, why does the amount of green M&Ms matter? Like, would you have a cow if you had more green M&Ms than blue ones?
I mean, I don't care. Some people think some are better than the others.
They all taste the same. Well, Skittles don't, but everything else.
I don't know. All right.
A.
Public health statistics indicate that 26.4% of American adults smoke cigarettes. Using the 68, 95, 99.7 rule, draw and label the distribution of the proportion of smokers among a randomly selected group of 50 adults. And then, do you think the appropriate conditions necessary for your analysis are met? So we'll do that part second. So, our mean is what?
0.264.
0.264. Standard deviation is what?
The square root of 0.264 times. Hold on, I gotta do the actual math. That I got. Someone else can say that they have it because I'm
0.736.
taking a line.
0.736
Over 50.
all over 50.
Oh no, my thing is slanted.
Point
0.062. So it says to use the 68, 95, 99.7 rule. So that means we need to
Draw.
draw a curve.
My other one looked really good. You see it?
Nice. That is really pretty.
Thank you, thank you. I'm determined by the end of this stats class I'll be able to do this normal model thing or whatever this is. I don't even know what this is.
It is a normal model. You're right, bro.
Okay, good. Makes me happy.
The first one is point. Oh wait, after the mean.
Yeah.
I got 0.326.
Okay.
0.388.
Okay.
.45. And someone else wanted the other one.
0.202. I did that in my head. I don't really know.
That's right.
Point 14.
I think I need to make my mom.
0.078.
All right, so where does the 68 fall?
Very, very far out. Wait.
The rule, sorry, labeling the rule.
It's the first standard deviation.
The first.
Okay, so
I was
68.
like, dang, that's bad.
95.
Second.
And 99.7.
A third. Go team.
So then it says to check the conditions.
Let's see. Oh, goodness gracious. Oh, what am I doing?
All right, so is it random?
Yes.
Check. 10%.
Oh, yes.
Okay, because 50 adults is less than 10% of all American adults. Success failure.
Yeah.
So n times p is greater than or equal to 10 because 0.264 times 50 is 13.2 and n times q is greater than or equal to 10 because 0.736 times 50 is equal to 36.8. So appropriate conditions are met.
Are we stopping for this one?
So yeah, normal model is appropriate.